So hi everybody, and welcome to this session. We felt that there was enough interest for us to do a deep dive into KERI ACDC. What I will do is today I will talk about vLEI specifically. So the goal of this session is to really talk about vLEI, Verifiable Legal Entity Identifiers, and how they actually using KERI ACDC. Because generally speaking, KERI ACDC can do all kinds of things in supports of kind of applications. And that's what actually makes it hard to understand because of all the optionality. And there is existing, usage which doesn't use every possible feature of KERI ACDC. However, enables lots of different things, and that's what we're going to talk about. And at the end, I'll do a little demo of a library I've developed. It's open source, and we can see how that works. So basically, this is the picture that all of us know, and I think developed together, because it's important when we talk about credentials. Technology is one thing, but why would anybody use technology in the real world, right? So you need to have technical trust, you need to have human trust, and that's very, very important, right? Especially specifically when we talk about organizational identity, because in organizational identity, we talk about contracts, we talk about obligations, we talk about all kinds of legal aspects, and therefore the governance aspect is very, very important. And with vLEI, we have actually very solid foundation on both sides. LEI have been around for 10 years, as we all know, and they have a working global governance ecosystem, and now they added this technical layer. So let's jump right in. So talking about the governance, I mentioned LEI, legal entity identifiers, and legal entity identifier is basically just a number which points to a central database that GLEIF, Global Legal Entity Identifier Foundation, maintains, which has all kinds of metadata about companies. And as I said, they have this federated model how they collect the data about the companies. And they actually rely locally on every jurisdiction on the local company register to collect that information. So that's the LEI, and it's open. You can go on the website, look for it, find up-to-date information about the companies, who they are, what the local register number is, the address, the ownership structure, and things like that. So that's the LEI essentially. And as written here, it's been set up as an answer to the global financial crisis, because back then they couldn't figure out who owns what whom and who might have liability and exposure, because these relationships between different financial intermediaries were not easy to understand. That was the answer back then, and it's still today. LEI is primarily used by financial intermediaries. So if you're dealing with any type of financial assets, you need to have an LEI, or if you're a big corporation like Swisscom, for example, you also have an LEI because of money laundering and other different types of procedures, but you usually just get it and then you register it somewhere and then you forget about it. So that's the LEI. Now, there is efforts to incorporate LEI into anti-money laundering procedures, ESG reporting, and all kinds of other different things. However, it has been used in a very narrow scenarios. GLEIF said, like, okay, how can we actually, work for the community? Because GLEIF is a non-profit global organization, right, with the mission to provide that information. So they felt like, okay, how do we use that for other scenarios? And they said, okay, so the verifiable credential is an important thing, and maybe we can use LEI as a basis for verifiable LEI, right? And so with verifiable LEI, you basically have a few key elements such as root of trust, the qualified vLEI issuers or QVIs, and we need to all get used to all kinds of acronyms in this session. So then you have organizations, and then you have persons representing organizations. So already vLEI, as you can see, is enhancement, because in addition to just the companies, pointing to the companies, you actually have now people representing different roles, right? And we'll take a look at what these roles are. What we're really trying to do, right? We're trying to create the basis for a completely electronic way of representing roles and mirroring the real world in the digital world. So we have just different things. So basically, the vLEI consists of three major credentials. So you have your legal entity identifier, and that's just a wrapper around your LEI number. So to have vLEI, you need to have LEI first. Then you have a person who might have some sort of role. So that's a string basically, and it's actually there's two types of different roles. You have what they call official organizational roles as well as extended context roles. And official organizational roles are standardized. So there's an ISO standard that talks about that. LEI is also ISO standard. And then enhanced context roles can be anything, which is not necessarily added to your official documents about your company. But, this is how the mirroring works, right? So you have your roles, the person, the organization, and they map to the verifiable LEI credentials, essentially, right? So how does this work? So how can we ensure that this mapping actually works? So first of all, the foundation for the whole thing is GLEIF root of trust. So the way that works is it's a multi-sig groups, and we will take a look what these multiple signatures look like, or multi-sig groups look like. It's actually not a fancy crypto. It's a very straightforward approach. So you basically have a group of GLEIF authorized representatives or GAR. That's one acronym we need to get used to. And then they use then basically they delegate two type of identities. So you have something called GLEIF, internal delegated AID representatives, or GIDA, and then external called GEDA, right? And the goal of these two things, and we'll see them in practice, is that the GIDA AID or autonomous identifier is basically for the controllers that act on behalf of GLEIF as organization to issue credentials to, for example, qualified identifiers, qualified verifiable issuers, QVIs, and GEDA is another, the other way around. Actually, the GEDA is the one, the external one that's used to sign the credentials for QVIs. And GEDA is something where they work as a receiver of vLEI, because if you go to a GLEIF website and look for a global legal entity identifier foundation, you will find that they also have a vLEI and official organizational role as CEO. So that's issued by QVI to them. However, to create QVIs, they need to have another key, the GEDA key, right? Controlled through the controllers, basically, right? So that's as written here. So far so good. So basically, the root of trust in this case establishes the GEDA, and GEDA establishes the trust to the qualified vLEI issuers. So far, it's kind of similar to how certificate authorities are doing this, right? Yeah, so now taking a look at qualified vLEI issuers, there is actually a very robust governance framework. I'll briefly show what it looks like and how this works. However, it's all online. It's a living document. You can all read what it is. But just to summarize for us, the qualified vLEI issuers, and again, remember, right? So we're doing the same thing, or not we, I mean, the GLEIF is doing the same thing that they've done for LEIs, where they have the federated programs, where they qualify the local operational units that issue LEIs. For example, in Switzerland, the Bundesamt für Statistik issues this. The Federal Office for Statistics, is one of the operating entities. However, the same thing happens for vLEIs. You also have these entities that are qualified through the program, and they need to adhere to service level agreements for their key activities. And what happens is the QVI reports issuance of verifiable credentials to GLEIF, which are then published as part of their database, which you can see, right? As I mentioned, you can go and find the credentials there. Now, what happens during this issuance, the QVI, they check the compliance of LEI first, right? Remember, you need to have LEI first, and then they actually, as part of this SLA, they must revoke vLEI credentials if LEI is not renewed or is not in compliance within 24 hours. So, so this way, the metadata is guaranteed to stay fresh and accurate. But there is also a crowdsourcing process. So if you see something is not accurate, you can also file a challenge through GLEIF themselves, right? So you can also do that. Going further, kind of visualizing this relationship. So you have your global, so GLEIF external identifier with the controllers, which delegates and I'll explain what delegation is slightly later, to QVI, to their identifier that they need to have, that they also control, as a group. If something happens on the key level with the QVI, because of this delegation relationship, they actually have to cooperate with getter, right? So they need to rotate the keys. For them to rotate the keys, they need to have the confirmation from getter. And we will see what it looks like a bit later. Just remember that delegation means that the keys, they stay in connected relationships. So the keys and events of the delegate cannot be completed without the involvement of a delegator. So delegator has a lot of influence on the delegated keys. So just looking at some of the framework fundamentals, because obviously, binder holding is important. The framework basically says that QVI must ensure holder binding, which means that, and we'll take a look at the role slightly later, of the people who represent a legal entity. They each control their own set of keys. Collectively they control the identifier of their legal entity, and so to ensure that there's a correct people, the NIST standard is used, and therefore the certain level of assurance is guaranteed there, right? You do holder binding, you verify who people are, you verify that they have signing authority, hard evidence. For that you look at the documents, so you do due diligence. And you also verify that they have good standing around LEI, right? The legal entity identifier as well. And then it's done, basically. So bringing it all together, basically that's what it looks like. So key roles and different processes. So you basically start by identity assurance and signing authority verification, which I mentioned. I'm actually using usually the documents from a local registry office to verify who the representatives of the company, and look at the LEI status and attribution check. So that is done by the so-called qualified vLEI issuer authorized representatives, or CARs. And from the company side, there is somebody called a DAR, which stands for Designated Authorized Representative role. This is basically somebody who signs the contract. So if it's a very small company, there's only one owner, so okay, that's fine. If it's a larger company, they will also designate legal entity authorized representatives, or LARs. Those are the people that basically hold the keys and control their identifier of the vLEI, right? Once the contract is signed, the onboarding ceremony happens. During this onboarding ceremony, which is usually online event with the video and challenge response, mechanisms, you do identity assurance and authentication. You bring your documents to make sure that you are the person who is actually authorized, and you have the documents to prove it. And then you also in control of your key. So there's the key establishment procedure, right? And then there is, basically peer-to-peer challenge response and key cross-signing to make sure that, we don't have man in the middle and stuff like that. So it's actually quite interesting what happens. And finally, the inception event, we'll take a look at this, is then signed, and basically then the credentials are issued, and that could, completes the procedure for issuing the vLEIs, right? So in other words, just to summarize, it's a well thought out procedure with roles are well defined, using best practices, and really making sure that companies that are small as well as companies that are larger can effectively manage their electronic identity and really be in control of their keys, because then we can correctly model this relationship, that the representatives of the company are really acting on behalf of the company, and we know who they are, right? Which is, by the way, is not the same thing, because a lot of people actually try to model the company wallets by saying, hey, wallet is just an agent, and this agent is controlled through conventional AIM mechanisms inside the company where people just sign in. But then the problem with that approach is you actually never know who is exercising the wallet. Are they authorized people, not? And it probably doesn't make sense for simple use cases, but for more complex use cases, you actually want to make sure that the right people exercise the right agency within the role. So, and this system basically allows you to do that. So that was just a quick overview for us to get a little bit of understanding of how these things are working from the governance standpoint, why we should trust the system. There's actually lots of different documents they're listed here. And as I mentioned, this governance framework is based on essentially on the work done by Trust Over IP Foundation. It's a living process. You can see that some documents have been updated recently just to close certain gaps or to clarify certain things. So you can go to the website and take a look at this. It's an interesting read, actually. Hopefully that's all clear now. And we will go into the KERI ACDC foundations as used for vLEI ecosystem. And here, I think it's important to try to understand what is KERI ACDC, its ambitions. The goal here, as I understand it, is that, with the KERI ACDC, Sam Smith has tried to kind of learn from the past mistakes and say, you know what, we have a patchwork system of different security mechanisms, identification mechanisms on the internet that has never been designed as a system, and therefore it doesn't work that very well. We cannot rely on it. So why don't we start from scratch, right? And why don't we basically forget the existing like DNS, PKI, and everything else that exists out there, and create a system that is easy to understand in terms of its security characteristics and guarantees and assumptions that we can use to solve the trust issue. That's really a very ambitious target, and that sort of explains why things sound a bit different as we go through. But at a high level, essentially, what we have persistent unique identifiers. And by the way, why is that important? Because the LEI itself is a persistent unique identifier. So it doesn't matter if your company still exists or does not. It doesn't matter if your company still uses LEI or not. This LEI will exist forever, right? Because your past history should not be invalidated, right? And if you in the future, need to do some more transactions, you revive your LEI, you will have the same LEI, right? And therefore, the vLEIs are also going to be related to the same LEI. So it's important that your identifiers are staying the same, right, throughout the life of the system, right? So that's important. So these persistent unique identifiers, they are linked to evolving public history of key state, right? So unlike in PKI, what happens is you always create a new pair of keys, and then this pair of keys, your public key is signed by, the certificate authority. So every time you change your key, you have a new relationship. There is no history, right? Unless you go to, some transparency logs and try to find it through your identifiers, which is not that easy, basically, right? And integrity of this public history of key state is maintained by witnessed verifiable microledgers, right? So it's not one single blockchain, it's not a central system, it's a rather a combination of smaller subsystems and maintained by witnesses, and we'll take a look at this, is how this works. So what does that enable? So why are we doing that? It basically enables, and that's very important, it's not just the key mechanism, it's also verifiable data mechanism. So it enables the creation and exchange of uniquely identifiable structured data objects or containers. That's the ACDC part, for those of you who know, and we'll talk about it later a little bit. And where these objects that we are, exchanging these data containers are typed, they're versioned, integrity protected, machine readable, schema, basically, right? Where the status of this object, or which can be credential, is anchored in the history of key state of issuer identifier. So basically, whenever we use our signature to sign a data, a packet of data, the trace of that is in our history log, right? So if somebody cannot just abuse our keys without us noticing, essentially, that's an important thing, and which allows us to link the identifier and the data together, right? So we know who's it coming from, and it's uniquely correlatable. And basically, I think it gives you some understanding. Yes, so there's identifier, there's the keys that are rotating and changing, and there's some events related to that identifier. Identifier stays the same, and that enables us this very nice applications around verifiable data exchange, and therefore credentials as well, right? So that's the high level view. So how is that enabled? So basically, KERI stands for Key Event Receipt Infrastructure. And this receipt infrastructure looks like this, right? So you basically have a series of events that are linked in a chain, if you will, or in a log. And then if you have like inception, you have interaction, you have rotation, and you have another interaction. Just a few types of events. The events are typed. And basically, the key building block of both the key events and the data exchange is something called self-addressing identifier, or SAID, which is the same as autonomic identifier, or AID, for inception events. So you start with the inception event. We'll take a look what it looks like. Which basically, and the way that works is you basically specify information about yourself. You calculate the hash. You encode that hash, you put it inside of your event instead of the placeholder, and therefore you know what the hash of this event is, and therefore becomes your identifier. And that's by this process, it's evident why it's called self-addressing, right? And then you basically can have other events that are changing keys or anchoring something to the state, such as interaction, and each next one points to the previous one. They're signed. They use the hashes, and therefore you have kind of a mini blockchain, if you will, or a mini ledger of these events, right? So that's the important thing. So what I try to illustrate here is, in addition to events, each event will have a little attachment which looks like something like this. We'll take a look at this a little bit more in detail. What it is, it's something called composable event streaming representation, or CESR. And CESR is basically encoding format to be able to map the digital representation of signatures or other different things, the dates, pointers into like references, if you will, to the history and things like that, in a textual representation, such that we can add things together, right? And then encode and decode integrally. So it's basically alternative to things like CBOR and others. It's a bit more efficient. And the other important thing about this is, and the reason why it was created is, I mean, you can imagine where this whole infrastructure is not only for companies, but also for machines and processes and things like that. So it can be highly asynchronous, and so it should be efficient for streaming, and it should be extendable. And so unfortunately, a lot of standards that exist out in the formats, they don't meet that criteria. So and because we're creating a new robust system, the Sam Smith came up with this CESR representation as well. And basically, so if we were to summarize some of the things that we're getting out of this, we have a format versioning of these events. We actually can theoretically store events in different formats like JSON, CBOR, and so on. However, only JSON is used for the events for the vLEI ecosystem, and CESR is used for cryptographic data. You have cryptographic agility. That's very important. As we look at the events themselves, basically we represent the hashes and the signatures with the code, which means that for the next event, when we rotate the keys, we can start using a different algorithm, and nothing changes, right? Essentially, we're just starting to use different algorithm, and that's it, right? So it's optimized for streaming, as I talked about. You have identifier hierarchy, right? You can delegate things. You can anchor the data through the different events. You have updatable weighted multi-sig rules, and you have priority keys, right? So now you can have the whole picture. So it's a very sophisticated mechanism that allows you to basically really manage your keys and make sure that people really can control them, change and update them as needed, and evolve the system, as new use cases become needed or new cryptographic approaches become needed, right, and available. So that's an important thing. So I gave you a little bit of theory. So now let's look at practice. So basically what you see here is the actual KERI events. And these KERI events coming from, KERI demo. KERI is the SDK that exists out there. And typically, so this is, I mentioned exception event. So how do you create an identifier? So basically you take this JSON here, and because everything is sort of optimized, you'll see that the keys in this JSON object are just one-letter keys, staying like the version, the type, the digest, the identifier, and so on and so forth, basically. And then they have the values, which is normal, and you can see like the version. I mentioned that the events are version schema events. So here we see it's a KERI 1.0. And then basically it follows with the number of bytes, basically encoded in a certain way. And what it gives us essentially, when we look, when you think about parsers, right? And again, remember, again, the system was designed to allow, edge applications and efficient parsing. So the parser will see, oh, okay, so that's a JSON encoding. Okay, so how many bytes are left? This many. Okay, this is what I will wait for. So it reads this whole packet, and it knows, okay, this is a complete packet, right? And it says, oh, okay, what's the type? An exception event. The hash is changing. How can you have the hash of the event and put the hash into event? It's kind of circular. It doesn't work. And it doesn't, right? So what happens essentially when you create an exception event, or any other event for that matter, it's just for the exception event, you take the DNI field, which stands for digest and identifier, and put just a placeholder, right? In this case, like a 44 hash signs, essentially, which is clever. And then when you hash it, once you hashed it, you basically encode the hash, and this is a Blake 3 hash encoded using the scissor scheme, and then put into this field. Basically, that's what happens. This is how this mystery is solved. Then you see there's a sequence of the events. Then you see the number of keys. There's one, and this is the Caesar encoding of the Edwards public key, right? So then you have your prioritated keys. There's one, in this case, is one prioritated key, and it's a hash of the key. So it's not the key itself, but the hash. Therefore, it's quantum resistant. Then you see, okay, so how many witnesses do I have, and how many witnesses should sign then to say that, hey, this is really event coming from me, right? And I'll explain what it means. It means in a second. So we have 3 witnesses, and you can see in this bluish type of color here, so you have identifiers or public keys of the witnesses themselves, right? They're signing this. Then there is a configuration and anchor that are not used for the inception event. And after that, you see the Caesar encoding, right? So the Caesar encoding, I formatted for your convenience. It basically consists of some control symbols that tell you, okay, so now what follows is a packet of data with encoded number of bytes. So I read that again. I can wait for this to come, and I know how many. So I read the whole packet, and within the packet I see, oh, okay, this is the first one. Okay, so this is the signature of the controller, right? And I say, okay, so there's only one signature. So this is the first signature. Here's the signature of this key, of the first key, right? So the key goes in sequence, and therefore the signatures point, okay, which key that was. The first means the first key, the second key, and so on and so forth. So, and then there is a signature group from the witnesses. So again, corresponding to the to their sequence here. And finally, there is this is something that is basically metadata from the witness. It says, this is when the witness saw this event, basically, right? And then it follows by the second event, which is in this case was IXN or interaction event. And again, we know which version of KERI it is, so it can the version of KERI can be evolved. You can basically sort of upgrade your protocol as you go. So again, it has the digest done in the same way. So the identifier stays the same, right? So this is something that we created here. So it's the same identifier. Sequence is number one, and where the chaining happens with events, you see the P stands for previous. Basically, that's the reference to the digest of the previous event, right? The D field and P field is the same. And here we've actually we anchored something. So remember, we talked about how we can add the references to credentials. For example, here we see, okay, so in anchor field, which is an array, there's an object which has three fields, I, S, and D, which is one type of a seal events, which means that it points that, okay, so there's identifier that we used. For this identifier, we anchor in event with event 0 with the digest this one. And typically that means it can be registry or it can be a delegated event and things like that, right? And then there's a scissor signature. So this is what it looks like. I probably gave you a lot of details, but I just want to actually demystify the whole thing. In reality, this is actually quite straightforward, right? With some specificity that you need to know, but there's nothing more than that to the whole thing. So we talked about witnesses. So we said like, okay, so yeah, I mean, anybody can publish this, but how do you know this is the history of the identifier? And basically, this is where the witnesses come in. So AID controller, the person who has access to the private public key pair, in this case, there's only one, but can be many. And we'll see example of that using something like a wallet. They basically sign the event. And then what happens is, and remember, right? So here we said we have three witnesses, and this is the ID of the witnesses, right? Their public key, right? Their identifier of the witness. So which means we have committed to these witnesses, and now this what I'm doing. I've signed my inception event, and I send it to these three witnesses. And each witness will take a look at this. They will verify that this all works together, right? The digest is correct and everything is correct, the signature is correct, and the rules are observed. And then we'll store it in its own database, this event, and then we'll provide a receipt, meaning its signature. So the signatures here, right, they basically come from witnesses. So what I do is I send to one, I send to another, then I collect responses and I send those responses to all witnesses because I said I need signatures from three witnesses for this event to be considered to be final and binding. And that's a very, very important concept because this is basically, that means that if there is an event has only two signatures, you cannot hold me accountable. If I give you false history and it is signed by all my witnesses, then I am actually duplicitous and you can hold me accountable. So that's the idea of the whole thing. So this is what happens. And then the witnesses, they basically maintain the kill. So sometimes people ask, what are the witnesses? Witnesses are just small servers, right? They're actually not that complex. There's obviously lots of rules that one need to verify, but it's not very difficult. You basically start them, and witnesses can be shared between multiple AIDs. So, and that's what happens quite a lot. Now, the rules of the vLEI network state that basically the QVIs, they have their own pools of witnesses for their AIDs. However, their customers, companies like like us, can actually share the same set of witnesses. So, for example, if you go to Provenant, which is one of the QVIs, they have a pool of witnesses that is shared between multiple customers, essentially. So there's networks of this witnesses that are all over the place. Now, I talked about multi-sig. And usually when people talk about multi-sig, they think about, Schnorr signatures and so on and so forth. Some sort of fancy crypto. Here is actually very, very simple, and I find it quite fascinating. So basically, in my keys threshold field, KT, what I do, in the array, it can be array or a number, and if it's array, that means there's multiple keys. I say the weight. So basically, it means that the first key here, the DFK, basically has weight 1/3. So as soon as I have any of these three keys that add to 1, I achieved my threshold, and therefore the event will be considered to be signed by the authorized controllers, essentially. And the same thing I do for the next keys, where again, remember, these are the hashes of the keys. So that means when I rotate the keys, any three of these need to be present for the rotated key to be accepted. With the scissor encoding, for example, the D here means a certain type of key. So if it also means that I can rotate to a new type of key or have a combination of different type of keys within my controlling my event or used by the controllers as well, which brings this very nice agility, cryptographic agility that does not create problems in terms of malleability of or vulnerabilities of this cryptographic signature. Delegation. I mentioned that there's example, the GLEIF root and GEDA, the external key that controls which issues to QVIs, and QVIs are also delegated as well. So what it means this. So basically, I am a delegator here on the left, and here's the delegatee or delegate key event log, and there is a type of event called delegated inception. So when I create this delegated exception in my configuration, I'm basically saying, hey, I'm pointing to my delegator, right? So as soon as I done that, I basically give the digest to my delegator, and then they anchor that, right? So remember, we had this identifier, sequence, and digest. This is what it will store. So delegate identifier is I, the sequence is 0, and the digest is the digest of the delegated exception event, right? Which means that basically the witness, and then there's can be two different witness pools, one for the delegate, one for the delegator. And essentially, if and the witnesses, they know the rules, right? Basically, and anybody else should know those rules. They said, okay, so if I'm seeing that that this is a delegated identifier because it has a DI field in it, I need to verify this with the delegator. And if I'm rotating, doing like delegated rotation, before it becomes legal, there needs to be an interaction event or rotation event which seals this delegated rotation in the delegator cal. So that means that basically it's both a security measure, but as well as it can be semantic relationship, like, okay, this is somebody who I trust, or used for certain purpose, like in case of vLEI issuance, and that means that it's very difficult to hack this, because even if I manage to somehow get access to the keys and they haven't noticed it, because remember, they see how the keys are used. You cannot issue credential without anchoring something. Now, for this event to take root, I need to convince the delegator also to do this. It's actually very, very hard, and actually makes recovery much easier as well. Quite an interesting thing. And of course, there's some details here, such as scissor attachment will basically point back to the delegator scale event, the number of their, so you don't have to search for it. You can just open it and verify that yes, it is signed by the controller or the multi-signature of the controller, and by the witnesses, and in the A field, right? Remember, we had this thing here, basically, right? We see exactly the attributes of this delegated inception event or delegated rotation event, and then it's verified. So very robust. You might say, like, yeah, but basically, for me to send these events, I need to do this, a bit of a dance between the wallet and the witnesses, and it's kind of asynchronous. And what happens if I have an edge application that might be running on like a mobile phone or some sort of device that is not always connected, or maybe not as powerful. For this case, there is something called a KERI agent, or KERI, which is basically allows you to delegate this this complex dense interaction with the witnesses to this cloud-based agent, which stays under your control. So all the signing is done by you, by the device or wallet or mobile application, something like that, and the interaction with the infrastructure is done by the agent essentially. You might be wondering, okay, so if I'm looking at some sort of AID, the company ID, QV ID, how do I learn where the witnesses are? Because they are distributed, right? They can have their own witnesses, can be shared, can be dedicated, whatever. How do I find them, right? For that, there's a concept called out-of-band introduction, or OBI or UBI, depending on how you like to pronounce it. And it's basically a very simple thing. I'm giving you a URL, just typically just IP address. We'll see it can be also DNS, but can be just IP address, which will have the path with the OBI and the prefix or prefix of the AID or AID encoded, which basically, if requested via normal GET operation, will give you just a text file with the cal, essentially. Simple as that. So, and this text file with the cal will also include the endpoints of the other witnesses, the person. So I'm just giving you one, and basically because witnesses know of each other, right? Remember, they're waiting for the receipts they're committed to in the inception event. They will, each of those witnesses will give you the endpoints of other current witnesses, essentially, right? So this is how you know how to interact with it. So basically, controller one needs to provide, the endpoint to the other counterparty, and the other counterparty need to reciprocate with their own endpoint. And so this both wallets are now know how to the latest state of the keys, as well as they know how to find witnesses and update the state of the keys if needed, basically, right? Any questions so far? Because now we go into the ACDC part, the credentials part. The ACDC, or authentic chain data containers, has nothing to do with the with the band, basically, and the what they look like, again, this is all basically JSON documents, and they have a few things. So they have as usual this self-addressing identifier, the side, basically. You have the issuer AID, you have the schema, you have the registry. We'll talk about what it is. You have attributes, you have the edges, and you have the rules. And that's basically actually very, very interesting. I maybe start from the end here, because the rules is something that actually makes it a recording contract. I can basically specify what the legal terms are as related to this specific credential. I can, then the edges allow you to specify which other credentials this credential depends on. So attributes is basically the actual content of the credential. The registry is the concept of verifiable data registry, like we have in W3C credentials. Remember, there's, we always point to some sort of registry to verify, okay, how do you know this has been actually issued? The schema talks about exactly what type of credential that is, and then issuer ID and said self-explanatory, I guess. Now, the important thing is that when we talk about the schema here is also fingerprinted. It means that's also using SIDE. And the reason for that is, we don't want to rely on some external providers of schemas, because we don't know what they do with it. Because if they change the schema or give you incorrect one, we would not be able to verify the credential, right? It would be a type of attack. So we want to prevent that. And we also need to know which version of the schema we're talking to. And of course, then we want to seal this whole credential with the help of a SIDE. So the way that works is basically now that we have this, we have the edges pointing to other credentials. So these credentials can come from other entities. This is how we cross the trust boundaries, right? So now we can build this whole chain of different things that might come, not only across companies but across borders. And as long as it's all anchored within our ecosystem, we know how to deal with that, right? So that's actually very, very flexible. Being a sophisticated scheme that allows you to build like this directed acyclical graph structures, which allow you to describe almost any type of thing. So now we'll see how that works for vLEI, but generally speaking, this is the mechanism that underpins the whole vLEI ecosystem, which means that we can take what we have within vLEI with their governance and then extend it with the other type of credentials and so on and so forth. So there's a relationship today between the witnesses and ACDC. So basically, I mentioned that we need to anchor the credentials, and we do it by adding the same anchor they've seen for delegated. This thing happens for the delegated identifiers. The same thing happens for the credentials themselves. And the events about credentials, they call transaction event logs or TELs. And basically, first we create the registry, and then we basically issue a credential, and we can revoke it and so on and so forth, right? So, and currently the witnesses, they store both CALs and TELs. And there is now a bit of a debate whether or not it should be separate. That's how it works today. Now, looking at vLEI, so how we're using this set of credentials is basically the GLEIF creates a QVI credential, which they give to QVI. The QVI then issues the vLEI credential to a legal entity, right? And legal entity can issue extended context role, or legal entity can ask a QVI via official organizational role or extended context role authorization credential to issue ECR. However, for official organizational role like CEO, CFO, and so on and so forth, something will be in legal documents about the company. Legal entity will give a credential to the QVI saying, hey, we're asking you to issue a credential to this and this person. So it's on the record. And then the QVI does the KYC procedure on the person and then issues them the credential, right? Which can be then used for, for signatures, for issuing other credentials and so on and so forth, right? So basically you have a QVI credential, you have legal entity credential, official organizational role credential, and extended content role creation, and a technical credential to issue either OOR or ECR, right? So that's the summary. Technically, it looks like on this picture, it's probably too small, but basically, everything I talked about, like different edges and attributes and so on and so forth, give you the pointers where you can basically take a look and start verifying, the rules, the schemas, the digests, the relationship that need to exist between different relationship, and you can basically find out and verify a lot of different things about these credentials and make sure that they are. I mean, the important thing, I'm not sure if I talk about this here, but the interesting thing is now vLEI credentials are kind of public credentials, but if you, for example, were to start creating other credentials, they're linking back to the whole vLEI ecosystem, and that was confidential, which you don't want to disclose confidential information. The important characteristics of ACDCs is that within my attributes section, actually it goes for all the sections, in my attributes section, I can just specify the digest of the section, right? Without disclosing the rest of attributes, which means that once you accepted the credential for me, remember there's rules that can talk about, what's going to be in this credential. And you say, yes, I agree. And you sign it via your electronic signature. Now I have a binding relationship with you, and I can disclose the attributes behind this digest. It can be another, a set of attributes, maybe not all, right? And so on and so forth. So, now I can do this graduated disclosure, step by step, which basically models how we do things and does not require any type of fancy crypto, right? That's another interesting thing. Now, behind the scenes, there's this is the diagram. It's actually in my GitHub. You can see it. This is how this whole thing actually ties together, like formally from a modeling perspective. You have your schemas, you have your basically a credential. This is how it relates to the transaction event log and the registry and so on and so forth, right? So we don't need to stop here, but there's a model basically how it all works. Interaction between participants, basically the witnesses, and remember, right? This is all asynchronous. You need to coordinate the signing multi-signature groups. and so on and so forth. So witnesses, they have what they call mailbox mechanism, and this mailbox mechanism allows the wallet to work asynchronously with the witnesses, but also I can leave the messages for external participant that's not, the controller that witness is controlling themselves. So that's another important thing that exists there, just for your information. And basically, so now bringing it all together, so what type of infrastructure is needed, right? So actually, you just need two sets of witness pools, which can be the same but can be different depending on the company and the level of trust that you have between these entities. And then you need to have KYC tooling. Remember, there's this process how I'm getting access to information about the company or a person. I need to have a communication tool because the issuance is online process. I need to have a coordination tooling, like, for, inviting people. So for example, if I'm CEO of a bank, I'm probably going to have very little time and you need to agree with me, while other participants might have better availability. So you need to be able to kind of coordinate the whole thing with me. You need to have access via API to GLEIF, which is easy. And for example, if you want to do all in the same thing, procedure, doing the vLEI assurance along with the ELEI assurance, you can have API relationship to local organizational unit, and many of them provide that as well, right? So, and then you need to have some roles, depending if you're a larger company, then several roles. If you're a small company, just yourself is enough. And then, and then it all works together, right? So that's an overview, essentially. Just to make this secure, this is all that's needed, right? So you have your wallet software, you have your witnesses, and that's it. There's no, complex certificate, DNS, security, and so on and so forth. This is all. Yeah, the same thing goes for the OR, OCR roles. It's the same thing. You don't need anything more than that. You just need to have the people that hold the role to participate in the whole in the same kind of process. And generally speaking, right, so now we have the credentials, we know what they can do. How do I use that? So basically, so you have two legal entities. They start, accepting each other credentials. Actually, okay, so if you're just receiving a credential, you don't need your witnesses, right? However, if you are participating with your credentials in your AIDs, you also need to have the witnesses. And basically what you need to do, you need to do this out-of-band introduction procedure. So you learn about the CAL, the state of the keys, the witnesses. You go and verify the witnesses of the QVI. They will be separate. That's the rule of the system, of the ecosystem. You verify the status of the GLEIF, because you remember they delegate to the QVIs. So we need to be able to validate that here as well. They will also have they must have the separate set of witnesses. But other than that, that's it. Now, once you receive the signature and out-of-band introduction or credentials, you basically need to have a watcher. And watcher is a component that will be introduced for two purposes. There's a watcher in the sense that, I will always monitor my AID, and that's part of my demo. I'll show you how that works, just to make sure I'm getting the same history from many witnesses, and making sure that basically this AID is not lying, right, about their state of keys. So that's one, function of witnesses. Watcher, sorry. However, there's another function, which is basically the application function, where I'm monitoring this, and at any given time, I actually have the correct state of the AID, so I can get the public key and verify signature, or look at the events related to the credentials, so I can verify those. So you need to have another component, because remember, these things are stateful. So you need to stay connected to that state, essentially, right? If you need to maintain the relationship, but you can do it online as well. It's actually not that hard. It's just, I think, for high volume, low latency applications, you will benefit from something that constantly monitors this and does the calculation of that. In terms of usage, the usage is not that high at the moment. There's basically just two QVIs at the moment, the Provenant and NordLEI. NordLEI is participating in the European Banking Authority pilot. which is sort of outlined here. The goal of this pilot is that the banks, such as, and the pilot has been recently, one of the stages of the pilot has recently been successfully concluded. So like Deutsche Bank and others in Europe, they need to submit official reporting to European Banking Authority. And until today, it was done with the help of FTP, just uploading the files, which is A, not very secure, B, difficult to make sure you're getting the right data from the right people. And with this system now, we basically have a special role of the reporting submitter from the bank, which has the vLEI, which has LEI. So now when somebody submits this report, which is also signed by the bank, we know who submitted it, when it's coming from the right entity, and the whole process is much less error prone. Basically, that's the goal of the pilot. With that, that's the all about theoretical part. So basically, the library that I have created is called KERI. It's on GitHub. You can see it. So here's the library, and just a very quick thing. I mean, the reason I developed this was because I really wanted to understand how KERI CDC worked, and like many other people, I couldn't understand it by reading the white paper. So I decided to implement it and learn. And it's done in a language called Elixir. Elixir is basically a functional language on top of Erlang machine. And why Erlang and Elixir? Because basically now we're talking about communications, parsing and multi-processes, and it's actually very easy to do with Erlang, and it's very robust. Anyway, so it's very easy to start with this. There's something called Livebook. A Livebook is basically something similar to Jupyter notebooks that you probably all know from the Python world. This is an alternative. It actually works really well. So what I've done here, I've actually connected to my locally running instance of the virtual machine that runs my code. And now I will do, and this is part of the GitHub, so you can just install it and run it. It just explains how everything works. So what we will do, we will go through the process of working with the actual vLEI infrastructure here. We will connect ourselves to the GLEIF and QVI, and also see information about the keys and monitor them. So so first I need to do some setup, set up some databases, initialize some tables. So we've done the setup. So it's working. So we now need to define the AIDs to monitor. So it's explained here, and you can see this is basically what the AIDs look like. These autonomic identifiers, and what this is the addresses of the witnesses in this case, right? For both the different AIDs. So GLEIF root, GLEIF GIDA, GLEIF GETA, and provenant. So we will basically evaluate this. We will also define some monitoring parameters. So we will watch these things every minute, basically, that will be updated. So now we're going to introduce, right? Remember that we need to load the initial information from these witnesses. And you can see that we started to basically read the information and starting processing like different types of messages, right, from these identifiers. So now it's loaded. So we just loaded like 4 different KELs. Basically, some of them are quite lengthy, like 57 events. Now, so let's take a look. For example, GLEIF root. So we will get the state, and this is the calculated state. So you can see, oh, okay. So I see the previous establishment event. Here I can see that the type of the event. I see the sequence of the event. The digest, when I saw it, the keys, the threshold of the keys, the next keys, the threshold of next keys, the witnesses I mentioned, and the configuration parameter, in this case, this establishment on the event, and what the latest event was, right? So that's already a lot of information that we get about this. Now, because of delegation, there might be more than one type of, more than one state that we need to look at. It's all explained here. So basically, we can call the API and get for the GLEIF GETA, right, the identifier that since that signs the QVIs, basically, you know, it will get us the root one as well as the getter itself, right? Along with the keys and everything else. So now let's start with, let's say we want to watch all these identifiers. So we'll basically start a process which is started. And now we start basically every minute. It will go and basically get us information. Yeah, so and it will report basically every minute. It will report that, hey, this is what I have updated it, and if there is new events or not. Obviously, you know, it's not like Provenant or GLEIF do something every minute. So to demonstrate that I'm actually working, we're going to use a local demo witnesses and play with them, right? So I will introduce them right now. So you can see it's reading from my local address. So just added a few witnesses basically. And yeah, so now it's reading every 10 seconds, basically in the background, in addition to the ones that it's doing every minute. So I can add basically all kinds of AIDs and watch them at the different interval. So I'm getting the state for this demo witness, right? So I know, okay, so basically what we're looking is this, here's the current key, right? And we know that the last event was rotation event number 3. So now that we go back here, and here's the witnesses, and here's the me logged into this container. So let's verify, you know, what is the status of this identifier. And the beta says, okay, so identifier is this. There's 3 witnesses, and here's the latest public key. So let's check that this is the one. It ends with BYH, right? So, okay, what do we see here? We see the key, yes, BYH, yes, the last event rotation number 3. So let's change that. Let's rotate it again, basically. So it will do this. So sequence number 4, and yeah, so we see that we updated state. It picked it up. We see that the state has been updated. So let's check it again, and let's see. Yes, so now the last event is number 4. That's the digest of the event, and that's the new key. Is that the new key? XLNE. Yes, that is the XLNE. That's the new key, right? So now we can play with it as well. You probably heard about DID methods. So the DID method is defined for KERI, and then we basically can create the DID method from the database and also print it out, right? So, and here we have the DID WebS representation of this AID. So here's the AID, and here's the public key that we've just seen basically, and the type of the key and everything else. So yeah, so that's you know, the watcher, as you can see, it's updating. You know, it's watching like 10 seconds this local one, and every minute this external ones, and the keys are correctly calculated. It supports recovery, and it's actually very, very efficient. So yeah, so you can already play and explore and build even some applications. So what I don't have here is I don't have the verifiable credentials. The data is there, and if there is interest, we can do a deep dive into that, and I can show you how that works some other time, because we are over time and it's been a while. But yeah, you can see it's all the real thing.
Cool. Actually, I'm glad we recorded it. So I guess that was really a crash course, and I will have to replay it in a little bit slower mode, maybe. But one question. So your implementation right now, that's your local experimental environment, I take it. Is there actually a connection to the real vLEI world, or is it purely local?
No. As I explained, this first part, where I'm connecting to the CIDs, this is, as you can see from okay, let me go here. You can see it's all external. It's all real infrastructure. You
Okay.
just, what I cannot demonstrate here, I cannot rotate something so you can see, hey, I'm actually updating. That's why I started the local one. because in the local one I can change it because it's under my control. I don't have any vLEI myself. Maybe Tis has, and maybe he can rotate something, but then I need to introduce myself to his EID, and we can do the demo together, right? We can see how it works with the real infrastructure if somebody does it. But the data from this witnesses for GLEIF and for Provenant is real data from a production environment.
Okay, so I could actually use it, for example, to create the vLEI for my own company.
You will need to have software from Provenant to do it, to create your own vLEI and use it. What you can do with help of this library is you can use your vLEI, right? I can read your keys, I can get your state, I can verify it and do things like that.
So I can do the personal assignments if I get it right.
Yeah, it's on the receiver side. It's for relying parties. It's not for the issuers. It's for the relying parties.
Okay, but for the vLEI, I would have to reach out to one of the official providers.
Correct.
Okay, correct. Got that. Thanks.
Yeah. All right.
Thank you very much, Vasily. It was really a lot of information for all of those who have not heard yet a lot.